Okay, so what we were looking at the other day is we were looking at geometric sequences. So geometric was when we are multiplying by that common ratio, which is a number, and which we are about to start calling it, representing it with a big capital R. Okay, so what we're now moving into, we're going to look at geometric sequences, but with the finance application into it, using it. So if you look at, when we did arithmetic, we looked at the finance scenarios, which were simple interest, flat rate, unit cost, sorry. So now we're onto geometric, and our first one we're going to do is geometric growth. And that's what an example of that is compound interest. So compound interest, and you can see there you've got two little options here. You've got when you have loans or you have investments. So what compound interest is, so say for example for a loan, you go to the bank and the bank gives you some money, lends you some money so you can do something like, let's say buy a house. So the bank's not going to give you that money for free. They want to make money out of it. So what they do is they say, right, we'll lend you this money and you're going to pay it back, but we're going to charge you interest. We're going to add a little cost onto it. So what that means is, so then the extra little bit that you make you have to pay is interest, and that's what the bank does, and that's how they work their money. Now with investments, it's still compound interest, and it's still growth. It's in terms of the money amount is growing. So in investments, it's more that it's your money and you put it into a financial institution, could be a bank or whatever. And what they do is they take the risk and they say, well, they invest it in wherever they think, is going on. And then they'll say, all right, if you give us that money and let that money sit in our bank, we will give you some extra for letting, you putting it in there, and you'll work out an interest rate and you get extra. So compound interest is extra. Now the difference with compound interest and interest. Simple interest, if you say for a simple interest you had $1,000 and we gave you 10% every year. So that means every year you're going to get $100. So it doesn't matter if you had it for 5 years, you'll have $500. That's simple interest. What happens with compound interest? So if I just say compound interest, say you initially start with $1,000 and we times it by 10%, which would be say 1.10. You're going to end up at the end of say V1 will be 1,100. And then what they do is you then get for the next year, you'll get the 10% on that. So if you look at it, you're now going to get $110 extra in the next year. So then your total will become 1,210. So can you see it's the same percentage, but it's the actual amount that's going on is bigger, isn't it? It's because you're doing it on the new total. So that's what compound is. That's how it's different. And compound interest, to be honest, is what most of your financial scenarios in life will be. It'll be compound. Your interest on your home loans, compound interest. Your car loans, if you go to get a car loan at the sales place. Your super is it's an investment, it's compound interest. So most likely, the things that are simple interest are generally things like little things like off in a shop where you purchase, that I think like lay-by or, pay later. That's generally a simple interest scenario, not compound, but everything else is. So let's have a look at this. So we're now going to look at compound interest. So we know it's a geometric growth. Now we're going to be asked to write the recurrence relation for a compound interest scenario. So first of all, with a recurrence relation, so remember this column shows the recurrence. You're going to get asked to write the principal. Now the principal is, you might just want to change. It's just a word they use in finance for, say, the initial amount, or, the starting amount. So you can see that anyway. It's VO, so you probably have assumed that. And then when we write the formula for our compound interest, we're going to write for a recurrence relation, we're going to write this out. If that, see how the R is highlighted? That means when you do your scenario, you'll have to change that to some numbers, whatever the scenario is. Now, if you look, that R, if we're going to write, that's our common, so that's the formula here, is the formula to work out, the number you multiply by. So which is what we call the common ratio. So that's the common ratio. Okay? So that big R is our common ratio, but you're going to see it in the formulas now. We're not going to keep writing, common ratio. We'll use a big capital R. Now you can see in that formula there, it also has this little r in there. Okay, so we're going to use this little r. And if you look over here, it tells you what little r is. Little r is the interest rate per annum. So most of our finance things generally, and if you watch the telly, if you look at home, like when any banks are advertising loans or that, they will tell you, they'll say the interest rate per annum. So you'll see a rate often, and they might write PA, so just write that. So really what that is per annum means the yearly rate. Okay, so they'll give you, you're given the yearly rate. Even though you have the yearly rate, sometimes it's set up that you'll get your interest charged maybe every month. So what they do is they take that per annum rate, their yearly rate, they divide it by, say, 12, and then they'll say, right, we're going to add that amount of percentage every month. So what you divide it by, so if it's, monthly, you divide by 12. If it was quarterly, you divide by 4. That's called the PPY. So you can see in the formula there, we've got rate divided by PPY. So over there in our little, so you can see there, over here we've written PPI. So it's the number of compounding periods in 1 year. So it's got an example of if it was monthly, maybe just pop another one. So if it was quarterly, it would be R divided by 4. Say, and I'll just pop a few others down here. Okay. Okay, so if we had fortnightly, the PPY would equal 26 because there's 26 fortnights in 1 year. If we had, say, weekly, PPY would equal 52. And sometimes even you'll see that they're going to give you interest on a daily basis. So generally we say PPY is 365, and then they'll tell you if it was a leap year or something. They'll be much more clearer if they're going to do it. They don't really. They're normally just a normal year when we're doing our questions. All right, so that's what you're going to see. Now in the middle here is our nth term formula, which we'll use when we want to go, if we don't want to do it recursively, meaning find it step by step by step, we use the nth term formula. So you can see that that rule, the basic rule, we're using that big common ratio number again, the R, and then it's to the power of n, and then times VO. So because that R is highlighted, you're going to have to put a number there when you're writing the formula. And VO is also highlighted, which means you put what your VO is in the scenario. So let's do some examples. So the following recurrence relation can be used to model compound interest. Now this is the other thing we need to know. They're always going to tell you what type of interest it is. They will use the word compound if it's compound. They will tell you it's simple. It's simple interest if it is. They do not trick you. They have to tell you what it is. Okay? So we've got a compound interest investment of $1,000. So you can see that's our VO. Now, interest is paid at 8% per annum. So they actually told me little r there. Now, you can see they've already written up the recurrence relation. So I'm just going to show you that number there, the 1.08, is actually that common ratio, that capital R. So what I would like you to do is write on the side how they found that. So it was the rate remember this is the basic formula. So what they did is they went 1 plus the 8. Now, because this was just per annum, just a yearly formula, so it was just over 1 times 100, and that's how they got that 1.08. So you can see that's where that came from, because sometimes you're going to have to write it out. We'll find it and write it out yourself. Okay, so it says in part A to use this recurrence formula to find the values of V1, V2, the value of the investment after 1, 2, and 3 years. So that means we want to find V1, V2, V3. So because they said use a recurrence relation, you have to do those steps, and we're getting used to that. So for me, V1 would be 1.08 times the one before, which was 1,000. And then you get this 1,080. Then you have to show that V2 is the 1.08 times the one before, which was 1,080. And then you get 1166.40. And then you get V3. We have to show the 1.08 times the one before. And that one equals 1259.71. All right, so you must show that to get your marks. Now, just to remind you how you can do it quickly on your calculator to get those values. So remember, we type the first one in and we press enter, and you end up with the 1,000 sitting over there. Then the next thing you do, if you go times, if you press times straight away, it says answer, and you say, yep, the answer, so which is 1,000. You want to times it by 1.08. Once you do it, it ends up going like that, and you press enter, and you get the next one. Then you just have to keep on pressing enter, and you keep getting the next answer. So you can see I've got V1, V2, V3. Now in part B, it says determine when the investment will exceed 1,500. Because I'm so close, like at V3, I'm at 1,200 and something, so I'm going to keep going. So V3, then I got quick press enter, V4, V5, and I can see at V6, it's over 1,500. So there's my answer. So I'll just write V6 equals 1586.87. And why do you think I'm using 2 decimal places? Because it's cents. Yep, good. And we don't go any further than that when we've got dollars, so like money. So we just do 2 decimal. So we'll say, because V6, so we'll say after 6 years, it exceeds 1,500. Okay, so now Sally borrows 6,000 from the bank at interest rate of 4.2% per annum. So there's a VO. That was a little r, so it's good to just put that in. And let VN be the loan after n compounding periods. Okay, so write down a recurrence relation. So we've got to write a recurrence relation. If Sally's loan, if interest is compounded, so that's how you know it's compound interest. Now they're giving you a couple of different scenarios. So when they say yearly, that means PPY is 1. If it's quarterly, PPY must equal 4, and if it's monthly, PPY equals 12. So the reason we're doing that is because, and then we need to, these recurrence relations, they're going to look similar, except for their R value is going to look different. So if I write the formula for compound and the common ratio number, that big R, that's the formula. So if I do it for this scenario where PPY was 1, I do it like that, and I end up with the R being 1.042. Okay, so we know that the common ratio is that, so now I can write a recurrence relation. So a recurrence relation means you have to write the VO, which is 6,000, then you have to write the rule of how to get the next one. And the rule for compound interest is to write that capital R, which I've worked out, and then we write just VN. So there's the recurrence relation for that scenario. Now, if I do the same for this one, it would be 1 plus the rate, little rate, which is 4.2, but over 4 over 100. Now, just to make sure, when you're doing this on the calculator, I want you to do this exactly how we're writing it out. And the way you do that is when you press 1 plus, then if you go control divide straight away, one after the other, what it does is it puts that template there, okay? And that way you can write in exactly what we're just doing, so 4.2, 4 and 100. You must do it straight away like that before you enter anything in. Control divide, then it'll be set up the correct way. So when you do that, we end up with, this one will be the R equals 1.0105. So if I go to write this one's recurrence relation, still starts at 6,000, but the rule is a different, and it's 0.0105 VN. So just another thing to take note, just to make a reminder that you never round the common ratio, that capital R. You write every number there, so the capital R. So just maybe write all numbers. So once you work it out, so you can see I went to, that's actually 4 decimal places, write all numbers. You need to write them all out. Okay, so it doesn't matter how many there is, just write them all out. Okay, so then this last one, when we had a monthly, it'd be 1 plus 4.2 over 12 over 100. If you do that, you end up with 1.0035. So if I write the recurrence formula, I've got to write the initial, then I write the rule, which is 1.0035 VN. And that's the final one. The following recurrence relation can be used to model compound interest investment paying $1,000 at a rate of 10% per year. So the rate was 10%, little r was 10. And you can see here, we've got this, they've already done it, and there's our big capital R sitting there. It says, use a rule to find the value of the investment after 15 years. So when we have, when they say use a rule, you probably want to use the nth term formula. So we're going to find the nth term rule for compound interest. Okay, so if you go back, if you looked back a page, you'll see that the basic formula is this. Okay, so then in our scenario, I'm going to do that. So Vn equals, now I've got to write the R. I don't need to work it out. I can see it up there in the recurrence relation. It's 1.1, and I'm going to say to the power of n, and then times VO. Now I have to work out what VO is, but I can see it. It's 1,000. So then, if I need V15, all I have to do is 1.1 to the power of 15. So remember, that's to the power. So on our calculators, remember, you've got to do that little arrow key and pop that up there. So we do that, and we'll end up with V15 equals 4,177.25. Now it says up here to the nearest dollar. So what am I going to round it to then? 4177. So that means when it says the nearest dollar, that means whole number in financial. Okay, and there we go. This next question we will cover tomorrow. So it's not part, it's the next scenario. I didn't want to put it in there, but don't cross it out. We'll come back to it. Okay, a principal value of 20,000, so there's a VO, is invested into an account earning compound interest. So that's how I know I'm looking at my compound interest formulas. And at a rate of 6% per annum. So little r is 6. The rule for this investment after n years, so this is just a yearly rate, is given there. So I can see in there, here's my That's my big capital, that's my common ratio, that number in there. So they gave me the nth term rule there. So first of all, it says find the value of the investment after 5 years. So all we have to do is go, we want V5, and that would equal 1.06 to the power of 5 times 20,000. Now it asked me to the nearest cent. So this one is 26764.51. Then the next question, it says find the amount of interest earned after 5 years. So I actually want you to make sure you highlight this next bit, because this is going to be a rule that you probably need to use a little bit. So interest earned, so let's write that. Interest earned, I'm just going to give you a sort of a basic formula, equals the value at time. So in this example, they want the value at 5 years. And then we say we minus VO. So just underneath, I'll put this one's example. So this one would be V5 minus VO. So it's going to equal 26764.51 minus the 20,000. So how much interest they have earned by the end of 5 years is 6764.51. Then in question C, this is where you've got to be really careful. In finance, you've got to start making sure you read the questions very carefully. It said, find the amount of interest earned in the 5th year. So just in that 1/5 year, and to the nearest cent, it said. So what you have to do with that one, when it's interest in the 5th year, it means you do the value at of V5 minus V4. That will tell you what happened within that year. So we'll just write that. Interest in 5th year and underline 5th year, it's going to equal V5 minus the one before, V4. So we had to go over on a side note, go find V4, which would be 106 to the power of 4 times 20,000. And we get 25249.54. So then I just do, I already know 5 because they asked us to find that one. And then I'll minus 4. And just in the 5th year, they make 1,514.97. Okay? So that was that one. Okay, let's do D. Now, if interest is compounded monthly, so that means PPY has changed to 12. Up here, when it says years, PPY is 1. So it says if it's compounded monthly, write down the rule for the value of the investment after n months. So when they say write down the rule, just a rule after n months, they want the nth term formula. Okay, so what we do is we write the basic rule for nth term. So if you look at nth term for compound interest is r to the power of n times VO. But first of all, we have to find, this is a new r. So we have to find our new r. So r is 1 plus the rate over PPY over 100. So it's 1 plus the rate, which was 6% over 12 over 100. So we end up with 1.005. So now I can write a formula. I can write Vn equals 1.005 to the power of n, and then times VO, which was still 20,000. There's our nth term formula. Okay, and then the last one, it said use this rule to find the value after 5 years, which you've got to be careful too, because if we're going to a monthly scenario, 5 years is actually 60 months. So really, you're finding N60. So if you go value 60 equals, and we'd go 1.005 to the power of 60 times 20,000. equals, and we get 26977.00. So that would be 5 years after monthly. If you look up there, we had the beginning, A was 5 years after yearly. Which way would you want your compound interest to be charged? Do you want to just do it once a year, or do you want to do it every month? Why do you want to do it monthly? Someone said monthly. Why do we want to do it monthly? Because we're going to get more money. We're going to get more money. So the more you compound it, the more frequent you compound it, the higher it's going to go. So if you had yearly, quarterly, monthly, which one do you want? Monthly. If it's an investment. What happens if it's yearly, quarterly, monthly? What happens if it's a loan? What do you want? You want yearly because you don't want to pay the bank back as much, all right? All right, so let's have a look at this. It says the following recurrence relation is used to model. So we know it's compound interest investment, and they've given you a recurrence relation. So I'm not going to, so if we just quickly do the question, there we go. It says state the initial amount, so we can see that is 5,000. So that's okay. And so then the next question is what we want to look at, is it states the annual interest rate. So when they want that, that means the little r percentage is the question, okay? That's what we want to know. Now, if you think about it, when we have our capital R, which is that number at the front here, that was found by going 1 plus the little r over PPY over 100. So if you want to find, so we might write this down, so maybe at the bottom of your notes you pop this out. When we're finding the percentage rate, so I'm going to say when we're finding the little r from the common ratio, so I'm going to say the common ratio, which is our capital R, we're going to use this formula. What you can do is that you can say little r as a percentage equals, what you're going to do is you're going to take, first you're going to take the big R, and you're going to minus 1. So you have to do that first. Then you're going to times it by PPY and then by 100. So in our little example up here, if I was doing example B, if I'm trying to find the little percentage, I'm going to do the R, the big R, which is 105 minus 1, and then I'm going to times it. Now this is just yearly, so PPY was 1 and by 100. So what you end up is with, if you do that first bit, you'll end up with 0.05 times 1 times 100, so it equals 5%. So this sort of formula will work even if they've got monthly. You won't times it by 1, you times it by 12, okay? So if you follow this little formula, that will work every time. All right, so here we've got a recurrence relation, and then we know it's compound interest, and they've given us we've got the big capital R there, the common ratio. And so first of all, they've asked us to state the amount of money initially invested. So I can see that's VO, so that's 5,000. And the next question is, what state the annual interest rate? So that applied to this investment. When they say that, that means they want you to find little r. So you can see that little r is in our formula for our common ratio, that big R. So if you're asking, and I would like you to write this down in your notes, so put it in your notes book, what's in purple. So if you're trying to find the little r from the common ratio, so that's the big R, in compound interest, this is the formula you can use. It's written here. So little r is going to equal, the first thing you do is you take the big R, which in this case was 1.05, you minus 1, pop it in brackets. So you'd want to type this whole bit into the calculator. Then you times it by the PPY. Because this one was just a yearly investment, I only had to times it by 1, and then I times it by 100. So you'll end up with, the little r was actually 5%. So you could use this for any scenario. If it's a monthly formula, you'll times it by 12 in there, okay? So make sure you copy this down. This must be in your notes.